Hello everyone. Let's continue our discussion on circular motion. So now in this session we will discuss non-uniform circular motion such that the angular acceleration is constant, which is known as uniform angular acceleration. Now the angular acceleration, which is denoted by alpha, the instantaneous value is given by alpha is equal to d omega by dt. So for linear motion, we have equations v is equal to u plus at. Similar equation for rotational motion, we have omega is equal to omega naught plus alpha t. So the linear velocity, which is final velocity v, can be considered as angular velocity, which is final angular velocity. Now in linear motion, we have two directions, right and left. So right is considered as a positive, left is considered as negative. So in circular motion or rotational motion, we will consider angular velocity. So anti-clockwise direction is taken as positive. And we can call it outward or plus k cap. So similarly, the clockwise direction will be negative or inward. Clockwise direction is negative or inward or minus k cap. So suppose we have in a circular motion, particle is going anti-clockwise. So the angular velocity is anti-clockwise. So that is outward. If it is increasing with time, so initially the particle is slow, now it is increasing, now it is increasing, angular speed increasing like that. Omega is anti-clockwise and increasing with time. So we will say the angular acceleration is along omega. Omega is increasing, so angular acceleration is along omega. So we have omega vector outward, so alpha vector also outward. So this is known as acceleration in which omega increases. So we have example also. Suppose there is a fan, ceiling fan. When you switch on the ceiling fan, so initially the omega is 0, the fan is not rotating, but as time increases, so the speed of fan also increases. So that means alpha is along omega. The angular velocity is increasing, so angular acceleration is in same direction as angular velocity. So for anti-clockwise, angular velocity is outward, so alpha is also outward. Suppose there is a circular motion in which omega is anti-clockwise but decreasing. Omega is anti-clockwise but decreasing. So alpha vector will be opposite to omega vector. Now it is anti-clockwise, omega is anti-clockwise. So direction of omega vector is outward. So alpha vector will be inward. So in this situation, omega vector is outward, or we can say plus k cap, or we can simply say positive. So alpha vector is inward or minus k cap, or we can say it is negative. So in circular motion, for vector quantities like omega vector, alpha vector, angular displacement, these are known as axial vectors. So what do you mean by axial vector. So we have alpha vector, omega vector, delta theta vector, that is angular displacement. So these are known as axial vectors. In rotational dynamics, we will have torque also, torque vector, angular momentum. So these are axial vector, means their directions are along axis. Their directions are along axis. So what is an axis? We will discuss in detail in rotational motion. So now let's come back to circular motion. So we have a center here. So about this center, this particle is performing circular motion in anti-clockwise direction, and uh, omega may be increasing or decreasing. If omega is increasing, so alpha vector will be same direction as omega vector. If omega is decreasing, so alpha vector will be opposite to omega vector. So the first equation we have written, omega is equal to omega naught plus alpha t. So here omega is final angular velocity, and omega naught is initial angular velocity, and alpha is angular acceleration, and t is the time duration. T is equal to, actually it is delta t, which is a final time minus initial time, so it is known as time duration, the duration of time for which we are observing the circular motion. So suppose the moment you observe the circular motion, maybe the particle is at rest, so slowly it is spinning up, so you are observing the motion of that particle till the moment your observation finish. That is time duration, and when we denote it by t. So let's do one question based on this, and also we have to take care of unit. The SI unit for omega is radian per second, and alpha will be radian per second square, radian per second square. If we talk about dimension, so the dimension of omega will be t minus 1, because the angle is dimensionless quantity, and dimension formula for alpha will be t minus 2, because angle is dimensionless quantity. Angle is dimensionless physical quantity. It is a plane angle. Rate at which plane angle is changing with time, that is angular velocity, and rate at which angular velocity is changing with time, that is known as angular acceleration. Let's do one question based on this equation of motion, which is omega is equal to omega naught plus alpha t. Radius of circle is 2 meter. A particle start with uniform acceleration along circle from rest. So we have given omega naught is equal to 0. Find angular velocity after 2 seconds. So alpha is given in question. Alpha is given as, suppose, 2 radian per second square. So alpha is given, omega naught is given, and we have to find angular velocity after 2 second. So we will use omega is equal to omega naught plus alpha t. So omega is equal to omega naught, which is 0. Alpha is given as 2 and radius is also given 2. So that will be 4 radian per second. Omega is equal to 4 radian per second. Sometimes alpha is not given. Tangential acceleration is given. So the relation between tangential acceleration and angular acceleration is tangential acceleration is dv by dt and angular acceleration is d omega by dt. So we have the instantaneous linear speed v, instantaneous linear speed v is equal to radius times angular speed, or we can say the instantaneous linear velocity is equal to radius times angular velocity, instantaneous angular velocity. So if you differentiate this, dv by dt will be equal to r d omega by dt. R is constant, so we have tangential acceleration is equal to r times alpha, r into alpha. So in question, if tangential acceleration is given but we need alpha, so we can use this formula. So next question I'm asking, suppose linear speed is given as 3t, radius is given as 10 centimeter. Find angular speed after 3 seconds. So for this type of question, we can first find the tangential acceleration. So tangential acceleration for this particular question is dv by dt, which is equal to 3, and then angular acceleration we can find using this formula, at is equal to r alpha. So at is equal to 3. So this will be 3 by radius. Now radius is 0.1. So 30 radian per second square. Now we have to find angular speed after 3 seconds. So we will use omega is equal to omega naught plus alpha t. So we can use this equation because angular acceleration is constant. It is uniform. So omega is equal to 0. Initial angular velocity will be 0 because we know that initial linear speed is 0. So using this formula, when linear speed is 0, so angular speed is also 0. So omega naught is 0 because v naught is 0 and alpha we got 30. Time is given as 3, so that will be 90 radian per second. Next question, we have discussed in previous discussions RPM. So 1 RPM is equal to 1 round per minute. So it is the unit of omega, unit of angular speed. So what is the relation between 1 RPM and radian per second? So that is pi by 30 radian per second. Pi by 30 radian per second. 1 revolution per minute is equal to pi by 30 radian per second. So let's solve one question based on ceiling fan. Ceiling fan has blade length. So we have observed the ceiling fan. So they have 3 blades like this: first blade, second blade, third blade. So the length of each blade is given. Ceiling fan has blade length of 1 meter. It picks up speed 800 divided by pi RPM after 10 seconds from start. From start We are observing the motion for 10 seconds. After 10 seconds, the angular speed is 800 by pi rpm. Find angular acceleration. Find angular acceleration. So how to solve this type of question? Again, we will use the first equation of motion, which is omega is equal to omega naught plus alpha t. Omega is equal to omega naught plus alpha t. So the initial angular velocity is 0 from start. Start means it is at rest initially. So omega is equal to 0 plus alpha t. So we have alpha is equal to final angular velocity divided by time taken. So final angular velocity is given in the question. The ceiling fan, when it is started, it is picking up the speed. Initial speed is very less. So now speed is increasing, like this. It is becoming faster. So we have to convert this into radian per second. So 1 rpm is pi by 30 radian per second. So pi cancel, 10 cancel. So the final angular velocity is 80 pi by 3. Sorry, 80 by 3. So 80 by 3 whole divided by, now the time is 10 seconds. So this is alpha. So this 10 cancel. So alpha is equal to 8 by 3 radian per second square. 8 by 3 radian per second square. Let's do one question based on retardation. Angular retardation. So that is known as slowing down. So when particle in circular motion is slowing down, means initially it is faster, now slowly, now slow, now finally it will stop. So we can observe this type of motion in, again, the ceiling fan. Suppose it is rotating at very high speed. Now you switch it off. So after some time the speed will be less, and finally the ceiling fan will stop. So that is known as angular retardation. Initially ceiling fan is rotating with 90 by pi rpm. It stops after 1 minute when switched off. When switched off. Find angular retardation. So again, we have to first analyze the motion, what is going on in the motion. So in the previous question, it was acceleration. The omega is increasing. Now in this question, it is retardation. So omega is decreasing. So we will use the same equation of motion, which is omega is equal to omega naught plus alpha t. So final angular velocity is 0. It stops after 1 minute. Initial angular velocity is 90 by pi rpm. So omega naught will be 90 by pi rpm. Now rpm is pi by 30 radian per second. That will be 3 radian per second. Now time is given as 1 minute. Convert this into seconds. So into 60 seconds. So we have minus 3 is equal to 60 times alpha. So alpha will be minus 1 by 20 radian per second square. So this negative sign is showing that the alpha is opposite to omega, because the initial omega we have taken positive. So we can assume the fan is rotating anti-clockwise. So initially it is rotating anti-clockwise, now it is slowing down, and finally it is coming to rest. So in this case, omega will be anti-clockwise and alpha will be clockwise. Now, next question. Angular velocity changed from 3 radian per second clockwise to 6 radian per second anti-clockwise in time 4 seconds. Find alpha. Find alpha means you have to find the magnitude of alpha, also the direction of alpha. Alpha is clockwise or anti-clockwise. So same equation of motion, omega is equal to omega naught plus alpha t. Now clockwise and anti-clockwise. We know that anti-clockwise is positive. So final angular velocity is positive 6. Clockwise is negative. So initial angular velocity is minus 3 plus alpha into time. Time is 4 seconds. So we have 6 plus 3 is equal to 4 alpha, or 9 is equal to 4 alpha. So 2.25 radian per second square is equal to alpha. Now alpha is calculated as positive 2.25. So alpha is anti-clockwise. Alpha is positive, so that means it is anti-clockwise. So let's move on to the next equation of motion, which is S is equal to ut plus half at square. So this is for linear motion. So when we are talking about linear speed, linear distance, linear displacement, linear acceleration, so we have this type of equation. When we have angular speed, angular acceleration, so we will have similar equation, but instead of displacement, linear displacement, we will talk about angular displacement. Delta theta, initial angular velocity omega naught t plus half angular acceleration alpha times t square. So over here, delta theta is angular displacement. Suppose if we talk about one round anti-clockwise. Imagine a particle is going anti-clockwise. Like this, it is going anti-clockwise. In one round, what is the angular displacement? It is 2 pi radian. In one round, angular displacement is 2 pi radian, or we can say 360 degree. In 2 rounds, the angle theta, the change in angle or the angular displacement will be 2 into 2 pi, that is 4 pi. Similarly, if 3 rounds are there, so angular displacement will be 3 into 2 pi. So for n rounds, the angular displacement will be n into 2 pi. So initial angular velocity and time taken alpha we have discussed already. So now we will focus on delta theta. If it is anti-clockwise, delta theta will be positive. If it is clockwise, delta theta will be negative. Anti-clockwise. So suppose the one round is taken anti-clockwise. So delta theta will be 2 pi. If the round is taken clockwise, one round is taken clockwise. So delta theta will be minus 2 pi. For clockwise it is minus 2 pi. For anti-clockwise it is plus 2 pi. Now let's do one question based on second equation of motion. If angular acceleration is pi by 3 radian per second square, particle start from rest, how many complete revolutions it will cover in 4 seconds? How many complete revolutions it will cover in 4 seconds? So we will use delta theta is equal to omega naught t plus half alpha t square. Now starting from rest, and alpha is given as pi by 3, time is also given as 4 seconds. So delta theta is equal to 0 into t plus half into pi by 3 into 4 square. So we have delta theta is equal to pi by 6 into 16. Now we will replace delta theta with n into 2 pi, because when n revolutions are there, the angle covered will be n times of 2 pi. So we have 2 pi into n is equal to pi by 6 into 16. Pi cancel, so n will be equal to, again we cancel by 2, so it will become 8 by 6, or that is 4 by 3, so that is 1.33. So n is equal to 1.33 revolutions. If they are asking how many complete revolutions are there, so answer will be 1. Let's discuss another question. Starting from rest, it completes 6 revolutions in 10 seconds. Find alpha. So we will use the second equation of motion, which is delta theta is equal to omega naught t plus half alpha t square. So n into 2 pi is equal to 0 plus half alpha into 10 square. Now n is given as 6. So 6 into 2 pi is equal to alpha by 2 into 100. So we have alpha is equal to 6 into 2 pi into 2 by 100. So this is 6 into pi into 4 by 100. So 4 by 100 is 1 by 25. So this is our answer. 6 pi by 25 unit will be radian per second square. This is alpha. Next, we will discuss third equation of motion, which is omega square minus omega naught square is equal to 2 alpha into delta theta. This is final angular velocity, initial angular velocity, angular acceleration, and angular displacement. From initial angular velocity of 4 rpm, it is doubled in 3 seconds. It is doubled in 3 seconds. Find angular displacement during 3 seconds. During 3 seconds. During those 3 seconds, what is the angular displacement? So now to solve this question, we have two methods. We can use one more equation. We know that in linear motion S is equal to V plus U into T by 2. So we can use this type of equation. So we have delta theta is equal to omega plus omega naught into T by 2. Or another method is to find alpha first. So omega is equal to omega naught plus alpha t. We will find alpha, then we will use this equation, or directly we can use this equation. If we use this equation directly, so we will get delta theta is equal to omega plus omega naught into T by 2. Now initial omega naught is given as 4 rpm, that is 4 into pi by 30, that will be 2 pi by 15 radian per second. So final angular velocity will be 2 times. So 2 into 2 pi by 15 plus 2 pi by 15 into t. Time is given as 3 seconds. So 3 by 2. So this will be 4 plus 2. So that is 6 pi by 15 into 3 by 2. So this is 9 pi by 15 radian. So this is the angular displacement. This is one of the method in which we are using this direct formula. Angular displacement is equal to omega plus omega naught into T by 2. Another method is to find alpha first using this equation. So omega is 2 times of omega naught, and omega naught is 2 pi by 15. So omega will be, final angular velocity will be 4 pi by 15. Initial is 2 pi by 15 plus alpha into time, which is given as 3. So 4 minus 2, it will be 2 pi by 15 is equal to 3 alpha. So alpha is equal to 2 pi by 45 radian per second square. So this is alpha. Now we will find delta. We can use this equation to find delta theta. So delta theta will be omega square minus omega naught square by 2 alpha. So omega will be 4 pi by 15. So 16 by 25 pi square minus omega naught, which is 2 pi by 15. So 4 pi square by 225 divided by 2 times of alpha. Alpha is 2 pi by 45. So when we solve this, we'll get same answer, but still I will suggest use this direct formula.